Let's consider a 10% salt solution flowing from some vat, which we'll consider to be unlimited, into another vat of volume V. Maybe we're pumping this 10% salt solution out of a salt lake so that we have an essentially unlimited supply here. Now, there's a constant flow rate from this reservoir into the container, and solution is flowing out of the container. So the overflow also occurs at rate R. Now R is, for example, expressed in gallons per minute, or some measure of volume per unit of time. So the constant flow rate indicates how much water is flowing out as a function of time. Now, container has volume V. We have 10% solution flowing in at rate R, and we have overflow coming out at rate R. Let Q of T be the amount of salt in the lower container. We want to set up a differential equation that allows us to determine Q of T as a function of T. The quantity of salt in the lower container is a function of T. Now, whatever Q of T is, the concentration of salt in the container is Q of T over V. That would be like in pounds per gallon, or grams per gallon, or ounces per gallon. It's the amount of salt we have per unit of volume. How much salt, at what rate is salt flowing out of the container? Well, the outflow rate is R. The concentration is Q over V. Now that would be Q of T over V, but we're understanding now that Q is a function of T. So the rate of change of Q is Q over V, the concentration, for example, in pounds per gallon, multiplied by R, which is the rate at which water is flowing out here. And I say rate of change of Q, I mean rate of, let's call it output of Q, the amount of salt that's actually flowing out through the overflow. Now we also have salt flowing in. The rate at which salt flows in is going to be just 10% of R. We'll get that in a minute.